Nice. Compare what you got with what I got if you were here yesterday. Liam, you were not. All we did was we introduced the cube root. Works similar to the square root. Hassan also was not here. It's true. I am running out. But I feel, hey, wow, shots fired. Nice catch. Okay, so sliding them back up. There's the bottom ones. Are there any questions anyone would like me to do? Jordan, do you have any questions about any of this stuff? Which one? What number? Oh, they're not numbered. This guy? 66, the bottom one. Okay, so if I could have all y'all stop talking, that'd be lovely. Let's do the last one where the answer was 66. So this one, again, you guys are allowed to use your calculators, but I still want you to show me your work. So Hassan, what you're going to be doing is to use your calculator to find each of these cube roots. The cube root of 64, your calculator will tell you is 4. The cube root of Hamid and Abdullah, stop talking, please, of 4,096, your calculator should tell you is 16. And the cube root of 8 is 2. And now we're going to go back and we're just going to insert the mathematical operations that were in there to start. So the cube root of 64 times the cube root of 4,096 plus the cube root of 8 is equal to 4 times 16 plus 2. Jordan, you with me? Because you asked about this question.
Yeah.
And then the last step is to actually just do this multiplication. Your calculator will tell you 4 times 16 is 64. The plus 2 hasn't happened yet. BEDMAS says the multiplication happens first. And then the addition. Please stop making noises. Which one do you want me to do? This one? This one right here? Or this one right here?
That one. Yeah.
Okay. Well, some of these are just like the ones above them. The cube root of 2,744 is 14. This one is 7. And this one, the cube root of negative 8 is going to be negative 2.
Yeah, but this one has times.
It's true. It has times and division. So when it has times and division, we're just going to work left to right. You multiply 14 and 7 together, and you should get 98 divided by negative 2. 98. Well, positive divided by a negative is going to be negative. And then half of 98. Thank you. It's 49. There it is. So yes, you're allowed to use your calculator, but I still need to see the step-by-step. You forgot that you dropped the minus sign on the negative. The 2 probably then. Okay, so we're looking at applications of squares, roots again, and something called the Pythagorean theorem. Flip the page. Here we go. You sound very excited about the Pythagorean theorem, Ethan. Tells me you've seen this before. Excellent. Here we go. So, the Pythagorean theorem. Pythagoras was, I'm going to add a word in here, allegedly. Does anyone want to know what this word allegedly means?
Yeah.
What does it mean, Ethan?
It's like someone did something,
So it's like it was suggested, but we don't know for sure if it was true. So Pythagoras was allegedly a Greek mathematician. The reason that I'm going to add the word allegedly in here is because we don't actually know if a guy named Pythagoras existed. What we do know is that there was a group of mathematicians, and they called themselves the Pythagoreans. And often how school worked back in the day was people would gather around one really smart person, name their group after that person, and they would be usually his students. So like Plato had a school, Aristotle had a school, Socrates had a school. And some of these guys were, like Plato was the teacher of Aristotle, who was the teacher of Socrates or something to that effect. So we know the Pythagoreans existed, a group of mathematicians. We don't know if this guy existed, but we assume, based on the existence of this group, that a Greek mathematician existed, and we know that out of this group, they had some really ridiculous ideas. Some of them were totally bogus, as you know happens when you're in sort of a math cult. But one of the things that came out of this group was the relationship that we call the Pythagorean theorem. What they found is that for a particular kind of triangle, now this only works if you have a right triangle, and a right triangle has a special angle. What does that symbol mean, or what does a right triangle have that other triangles do not? What does this square represent? Does anyone remember? Nope. This is a right triangle because the angle measurement of that corner is 90 degrees. That's why we put a square in there. We say if things are square, they are 90 degrees to each other. And what they found was that if you took the hypotenuse, which side in this triangle is the hypotenuse? Does anyone remember? Okay, well, I will tell you. The hypotenuse is the side that's always across from the 90. So you find the 90, the side across from that is called the hypotenuse. And what they found is if you took the hypotenuse and you made a square out of it, you tack a square onto the hypotenuse, and so the square means that each of these side lengths is supposed to be the same length as the hypotenuse. What they found is that the area of this square is equal to this square plus this square. They found that if you added these two together, the areas, you take these two, you add them up, they will equal this big orange guy over here. And that is kind of an interesting relationship. What that allows us to do is if such a relationship exists, it allows us to find one of these sides if we know the other two, which is useful in math to be able to do something like that. These relationships are useful. So the way it's worded up here at the top, they found that the square of the hypotenuse of a right triangle is equal to the sum of the squares of the other two sides. Now, we simplify this down to a nice little equation. Does anyone remember the equation? Okay, well, then let's take a look at it here. To create the equation, we're going to label these sides. We're going to give them letters.
Which is X, Y, and Z.
You couldn't be further from the truth. Literally, it's at the other end of the alphabet.
A, B, C.
It's A, B, and C. You picked the last three, it's actually the first three. You couldn't have been more wrong, Garrett. That's okay. The letters are A, B, and C. C is always the same side. Careful, Denny. Or is it done? Can you go recycle it? Slam it, go recycle it. C is always the label for the hypotenuse. So then to find the area of this triangle, the area of this square is going to be C times C. So the area here is equal to c squared. Now the other two sides are labeled A and B. It doesn't matter which one you call A, it doesn't matter which one you call B. So I'm just going like this. I'll call this guy A, I'll call this guy B. So the area here is B times B, which is B squared. The area here is A times A, which is A squared. And they found that if you took A squared and you added it to B squared, you would find C squared. Again, like I said, some of the math results that the Pythagoreans came up with, wildly bogus. This one, super useful. And if you pay attention to math news, because so many people pay attention to math news, there was a group of high school students actually, like in the last couple weeks, provided a proof for this that was actually brand new to the math community. They'd never seen it before. A plus B is not C. A squared plus B squared equals C squared. Nope. No. This is the relationship. The area of this square plus the area of this square is equal to this, the area of this square, for every right triangle. It does not matter what these side lengths are. And there's a whole bunch of these, Hassan. No, this is just the end of the exponents unit because it uses exponents and roots. It's just using the stuff we did yesterday and the day before. It's not the beginning of a unit, it's the end of this unit. So, let's use this. If we know the hypotenuse, but one of the missing shorter sides, there's two other equations that we're going to use, and I'll give you all of these. We can use a squared is equal to c squared minus b squared, or we can use b squared is equal to c squared minus a squared. And I'll show you what I mean. Now, the one thing it's really important to remember here is when you're labeling, this one must always be true. The hypotenuse is always C. It doesn't matter what the other two are. So, let's do a couple examples. If I've got this triangle here, where is the right angle? Top corner, bottom corner, right corner? Bottom. Just by looking at it, you should be able to see which ones of those, they meet perpendicular to each other, they're square to each other. Where in this triangle is the right triangle? Top, left, or right? It's the right one. Excellent. Now, once you've identified it, go to the side across, and we're going to call it C. So in this one, this guy is C. In this triangle, the side that has the label 9 is C. C is always across from the 90. And now we're going to label the other two. It doesn't matter which one you call A, doesn't matter which one you call B. So I'm going to call this guy A, and I'll call this guy B. I'll call this guy over here A, I'll call this guy over here B. So now, in the first triangle, what side are we looking for? We are looking for a hypotenuse, we're looking for side C. So the side that you are looking for is going to dictate which of these three equations you're going to use. Because we're looking for C here, we're going to use this equation up here. We're going to use a squared plus b squared equals c squared. So now what we're going to do is we're going to take this, and draw a little arrow over here. We're going to plug in our values into this equation. A is 2, so this is going to become 2 squared plus Now we're going to plug 3 in because we labeled the side that is 3. We labeled it B, or at least I labeled it B. So I want to put 3 where B goes in the equation, and that's going to be equal to C squared. And now we're just going to let the math happen. What do I do first to calculate things on the left side? Do I add first or do I deal with the exponents first? Exponents first. So what is 2 squared? 2 squared is 2 times 2. 2 times 2 is? Just 4. Plus 3 squared is? Done. Cool. So that's equal to C squared. So then what's 4 plus 9? You betcha. So 13 is equal to C squared. I don't want C squared because C squared is the area of this. So what they're telling me is the area of this square is equal to 13. I want to find just the side length. We did this yesterday. If I tell you the area is 13, what do you do to get the side length? Or what is the opposite of squaring something? No. 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 Square rooting. What we're going to do is we're going to square root now. That's the whole point of the square root, is to find the length of the square if you know the area. You guys did this yesterday as part of your homework. So this is where, if I take the square root and square of something, these things cancel. And so we're just going to get C equals something. I'll need a calculator for this. What is the square root of 13? Sorry? Almost. 4 times 4 is 16. I'll grab my handy dandy calculator out, and we're going to find the square root of 13. Boom. And I'm going to round that thing to 2 decimal places. So what's it going to be? 2 decimal places. It'll be 3.61. 3.61. And this is the technique. Find the 90, label the sides, pick your equation, plug, and solve. Let's do it again. And then I will let you practice, and I'll walk around and help where needed. Okay, so I'm going to change the numbers on here to make our life. No, I'm not going to change the numbers. I'll leave the numbers the way they are. Okay, so given this situation, what are we looking for? Liam and Hassan. Hassan. Pay attention. We are looking for. What are we looking for? No, we are not looking for the hypotenuse. We're looking for A. So, which equation gives us A? Yeah, the A equals one, the top one. So let's write that equation down. A squared equals C squared minus B squared. We found the right angle. We labeled the hypotenuse C, and the other 2 sides get labeled A and B. It doesn't matter what order. And now we're going to take this thing and we're going to fill it in. We don't know what A is. That's what we're looking for. So it stays as A squared. This is going to be equal to, C comes first. C is 9. So it's going to be 9 squared minus B is next. B is 5. So it'll be 9 squared minus 5 squared. So A squared, now we actually go do some of the math. 9 squared is 9 times 9, which is? I hear someone say 81. That would be correct. Minus 5 squared is 25. Now, yes, the C is the 9. A squared is 81 minus 25 is? You betcha, Dakota, it's 56. Now I don't want a squared. I just want a, Jordan. Wiggy, wiggy. Yep. So I want to find a. So that's going to be the square root of 56. This is the stuff you guys were doing yesterday. I want to find out what the side length is if I know that the area of this square is 56. So use square root. And your calculator will tell you that the square root of this number rounded to 2 decimal places is 7.48. You were so close, Ethan. Could have been more wrong. Could have been closer, but could have been worse. Okay. This is what I want you guys to practice now. Flip the page. There are 6 triangles. I want you to do them all. Except I'm going to change the equations up at the top. Forget those ones. I don't want you to use those ones. Use these ones instead. Scribble that out. Scribble this guy out. You got a squared plus b squared equals c squared. I'm also going to give you a squared equals c squared minus b squared. And I'm going to give you b squared equals c squared minus a. No, you're not completely lost. Don't be completely lost. Oh, they're not lost. We know exactly where they are. They're in the Bermuda Triangle. They're cooked. We know exactly where that one is too. Nice try. Okay, give these a shot. It's the same set of steps. Fine, Ethan, would you like me to write down the steps for you? Yeah. Okay, here we go. Step 1. Find the 90-degree angle. Find it first. Step 2. It's the corner. That is.
Like the corner that's like the number, you know what I mean?
No. It's the corner that looks like it meets.
Oh, yep.
Like a corner. Like, how else do I say it? 90 degrees. It's perpendicular. It's proper construction. I don't know how else to say it. It's this guy. Label the hypotenuse.
Is that the thing like opposite from it?
Yes.
Do that.
As C. So in this guy here, that guy right there is going to be C.
And the numbers don't matter, like 48 could be B, right?
Yes, correct. Step 3. Pick which equation. And this will depend on what you don't know. So in letter B here, question B, the unknown is side C. So I'm going to use the first equation here, because that one says c squared equals something. In this one, I know C, it's 10. I don't know A or B, depending on how you label this one. So depending on which one you call A and which one you call B, you'll use either one of these equations.
Are you using like those 2 equations for every single one of them?
It's these 3 equations. You pick one of those 3.
For the top 2?
These 3. For all 6 questions.
Oh.
All 6 questions follow exactly this path. Pick which equation. Substitute values. So the side that you labeled C goes where the C is. Liam, put your phone away. The side that you called A is where the A number is, Ethan and Denny. The side where you called B is where the B number goes. And then you solve. These are the steps. If you want them written out, that's it. Yes, Hassan. Can you go where? I would like you to show me that you can do 2 of these questions, and then I will free you to go to the vending machine. Because you had all of lunch to go to the vending machine, and you chose to hang out on the field. Sure, it was great. But you should have spent some of those 40 minutes getting something to eat. Okay, try these. Go.